carbon seems to be a very friendly element. So far, we have been looking at the compounds containing carbon and hydrogen. But carbon also forms bonds such as with oxygen, with nitrogen, with sulfur, also with chlorine. In a hydrocarbon chain, one or more hydrogens can be replaced by these elements, such that the valency of carbon remains satisfied. What does this mean? So far, we have talked about this hydrocarbons, in which we have seen compounds made up with hydrogen and carbon. So, when carbon makes bonds with other elements such as oxygen, nitrogen, sulfur, chlorine, so what actually happens? Some of the hydrogens are replaced by these atoms and they form new compounds. So now we are going to talk about functional groups. What is the meaning of functional group? From the words itself, we can try to understand it. Group means collection of some atoms, and functional, which means having an important role or else having an important function. So we can refer functional groups as groups of atoms having an extremely important role in the compound's functionality. What did I say? Functional groups are the groups of atoms which have an extremely important role in the compound's functionality, which means in the function of the compound. In simple manner, we can say that functional groups are the groups with definite properties. And these functional groups impart their properties in the compounds in which they are present. So, what are functional groups? They are the groups of atoms with definite properties, and these properties they impart to the compounds in which they are present. As we have discussed earlier, that the hydrogens are replaced by the elements like oxygen, nitrogen, sulfur, and chlorine. So, here in such compounds, the element which is replacing hydrogen, that is referred to as a heteroatom. Remember the word heteroatom. What is a heteroatom? It is an element which replaces hydrogen from its compound of hydrocarbons. If oxygen is replacing hydrogen from hydrocarbon, then oxygen is a heteroatom. If sulfur is replacing hydrogen from its compound, then sulfur is a heteroatom. These heteroatoms are also present in some groups. Let us see what are the groups. It is shown in this figure. Heteroatoms are shown in first column. Functional groups are shown. So this in second column we can see the examples of functional group, and in the third column we have formula of functional group. First heteroatom is chlorine or bromine. Now here chlorine or bromine is a heteroatom, which means chlorine or bromine replaces hydrogen from hydrocarbon. And what is the name of this functional group? Halo, which means when chlorine is replacing, it will have chloroname. When bromine is replacing, then it will have bromoname. Okay, that in general it is called halo group. Formula, that is Cl Br. In front of Cl and Br, we have a single bond sign, okay, as you can see. And what are these? Substitutes for hydrogen atom. Next heteroatom, oxygen. And when oxygen is a heteroatom, we have functional group like alcohol. The first is alcohol. Name of the group is alcohol. What is the formula? Single bond OH. As you can see, there is a bond between O and H. Two atoms are there, two different elements are there, oxygen and hydrogen, and they combine and they form one functional group. Okay, and in front of it, symbol for single bond is shown. Okay, when there is OH functional group, that is hydroxyl. Okay, OH means hydroxyl. Second is aldehyde, and C single bond H, C double bond O, that is formula of functional group. Then we have ketone, C double bond O. Now here with C, left hand side, right hand side, we can see single bond sign, which means with the compound, this functional group will be added. And the last we have carboxylic acid, C double bond OOH. That is the formula of functional group. So wherever we see C double OH, that is of carboxylic acid. So wherever we see free lines, what do they indicate? It means that these functional groups are attached to the carbon chain through these valency by replacing one hydrogen atom or atoms. We can replace it by one hydrogen atom or more than one hydrogen atoms. So these are the examples of functional group which you need to remember. What are functional groups? The groups of atoms with definite properties which impart these properties in their compounds and which play an important role in the functionality of compounds. And how are they formed? By replacing hydrogen from hydrocarbons with chlorine, bromine, oxygen, etc. Now let us talk about homologous series. If we try to derive the meaning of this word homologous series, homo means same. So we can say in general that a series having similarities. Okay. A homologous series is a series in which compounds with same general formula but different molecular formula occurs in immediate succession. Series means what? When the things occur in succession, one after the other, right? So this is homologous series. Again, I say a group of compounds which have similar structure and similar chemical properties which occur in succession but different molecular formulas. So easily you can remember the definition of homologous series as a series in which the compounds are having same general formula. Remember students, the compounds are having same general formula but different molecular formula and which occur in immediate succession. This type of series is called homologous series. Now, you will be thinking, why do we need to study homologous series? These homologous series have the compounds have similar chemical characteristics. Here I am using the word similar chemical characteristics. Does it true that they will have physical properties same? No. Here in homologous series, the compounds cannot have same physical properties. They are different. Only they have similar chemical properties. Here we have general formula to describe the compounds. And there is a gradual change in physical property, which means their physical property is changing gradually. Now, how to see this change in homologous series? So we have three types of homologous series. First series is alkane series. Okay, recall we have learned saturated hydrocarbons which are called alkanes, which have single bond between carbon carbon atoms. I have already explained you that there is a change in all these compounds by CH2. Now with this table we can revise it again. Methane has formula CH4, ethane C2H6. So here carbon is added by 1 and hydrogen is added by 2. Same way for propane, carbon is 3, H is 8. Again carbon and hydrogen are added by CH2. Same way for butane and pentane. What does this mean? Every time these compounds are increased by CH2 unit, they differ by CH2 unit, which means they have common general formula. Now here you need to remember the difference. CH2 is a difference, okay? It is not a general formula. Do not mix the both. CH2 is a difference. It is not a formula. Okay, general formula. General formula for alkane is CnH2n plus 2. Okay, CnH2n plus 2, which means if we have N as 2, then by general formula we can write it as C2H. 2N means 2 2s are 4 plus 2. 4 plus 2 is 6. So this way we can remember the formula. Remember, again I am saying general formula for alkane is CnH2n plus 2. Same way, if we look at homologous series for alkenes, so here the compounds are ethene, propane, butane, pentane, hexene, and they have formula as shown in the last column C2H4, C3H6. So here, how do they differ? Again, they differ by CH2 unit. Again, I am saying CH2 is not a general formula. Difference is CH2. Okay, so general formula for alkene is CnH2n, where n means number of atoms. So this you will get on page number 67 in your textbook. Formula, general formula. Remember, general formula for alkene is CnH2n. If you will remember this general formula, easily you can write. And at last we have homologous series for alkynes. The general formula is CnH2n minus 2. Alkynes are ethyne, propyne, butane, pentane, and their formulas are C2H2, C3H4, C4H6, and C5H8. So this way we have different homologous series. What is the general formula for alkane? This you can note it down. General formula for alkane is CnH2n plus 2. For alkane, general formula is CnH2n. For alkyne, general formula is CnH2n minus 2. By remembering these general formulas, you will be able to write the names and molecular formulas of the compounds. So here we will remember about functional group, the groups of atoms with definite properties which impart in their compounds. We have also seen examples of functional groups. We also discussed homologous series, a series in which the compounds are with same general formula but different molecular formula which occurs in immediate succession. Here we have seen for alkanes, alkenes and alkynes that their general formulas will be remain same, but the molecular formulas will be different. Let us take example of alkynes. Here general formula is CnH2n minus 2. That is same for ethine, propine, butane, pentane, but their molecular formulas are different. What are they? C2H2, C3H4, C4H6 and C5H8. Is it clear? So here we have completed functional groups and homologous series.